This is Server Talk with Alexey and Mike, helping demystifying computing so you can make the best decisions in your business.
Hey everyone, my name is Mike. I'm here with Alexey, who's been working at ICC for how long now?
5 years.
5 years officially, and unofficially for some time. It's his father's company. All right, so Alexey and I grew up together. We were neighbors pretty much our whole lives. And ever since I've known Alexey, he's been around computers, he's been around technology, and he's just been around this whole field. His father's been developing and growing this company since the very beginning for the last, I don't even know how long, since the early 90s.
Yeah, since the sun came out.
So Alexey's a real veteran when it comes to computers, when it comes to technology. You ask him about anything and he'll know the answer. All right, Alexey, so other than my introduction, what makes you such an expert in servers? Why am I coming to you to find out about servers?
I have a pretty good handle on the actual hardware. I know all the technology that comes out early on. I know all the technology that exists. I work with a lot of different people, and I see what they're looking for and where the industry is going. So I work with a lot of different markets. I've been doing this forever, so I have a lot of people that know me and been doing this for a very long time.
Right. So the way the show is going to work, I don't really know anything about servers. This isn't my field. I'm a marketer. But Alexey here, as we established earlier, is a server genius. So, as a total idiot, let me ask you this question. Alexey, what's a server?
So, a server is a very powerful computer.
That's it? It's just a powerful computer?
Well, for the most part, yes, but you can get into a lot of details and dissect it and see what makes it powerful. I can give you a few examples. Really, it's meant for, well, what applications? What are you trying to do with it? And to give you some ideas, take a look at your website. Where do you think it resides?
The cloud.
Well, what do you think the cloud is?
It's like there's
Nimbus. You think there's a little cloud?
Yeah, there's like Nimbus clouds, and the ones that have rain and what. That's not it. No. Okay.
It's computer server clouds, and they consist of a whole bunch of servers, and these servers are in data center, and they're designed to be in these specific environments where they produce a lot of power and cooling comes into play. Form factor, it's not your standard, your laptop or your standard desktop. It's in a special form to keep them cool. Mm-hmm. The connectivity of how they connect to the internet and how they connect to everyone is very important.
Okay. So you touched on a couple things there that are interesting. So as far as form factor, form is, as far as I understand, the literal shape, the casing of the computer, of the server, right?
Yep.
So what is the difference between, say, a standard computer you might order and a server when it comes to the form factor?
So a lot of servers are stored in a rack, and racks require their own form factor. So in the server industry, or actually in just about any industry, as long as the components are stored in this rack, they're known as rack units. A rack unit is roughly 1.75 inches in height, and so your servers can be multiple rack units. So they range from usually 1U all the way up to 4 or 5U. So a 5U rack unit is going to be 5 times 1.75, and that's going to be your system. And that's not your typical desktop box that's by your desk. Okay.
So, and then you stack these things like Tetris blocks in data centers, right?
That's correct. They're a little bit easier than Tetris blocks. You can imagine it as that horizontal bar that everyone just wants to fall. Well, it falls vertically and falls all over on top of each other.
Okay, gotcha. So that there's none of that crazy shape with like the 3 at the bottom and then the 1 in the middle.
No,
like they don't make sense.
They're usually just pretty horizontal always.
Okay, I gotcha. All right, so that's cool. We know the shape of servers, but that's probably much less important. It was just something that tipped off my curiosity. But it's something a lot less important than what servers are actually
what's more important
used for. Okay, what's more important, Alexey?
Well, the power of the servers.
The power of the servers?
Yeah.
All right, let's talk about the power.
Did you know in the last few years, the U.S. power consumption has steadily been increasing by 2 to 3% a year just in data centers?
Wait, hold on. So the power consumption of data centers, or the total power consumption has been growing by 2 to 3% because of new data centers?
The total power consumption in the U.S. has been growing by 2 to 3% a year because of data centers.
Wow. Okay, that's huge. That's a growth market. You're in a good industry.
Definitely. Well,
all right.
But the issue becomes is, well, how do we keep the power down over these systems? The power bill of these people are just insane.
Right, and the electrical expenses increasing.
Yeah, so
year over year.
It's definitely been a problem, and well, part of it is how do we keep the systems efficient and more powerful, but keep the electricity bill down. And keep in mind, with, what is it, Newton's laws or whoever, you have power, it comes into heat. So now you got to cool them down too. And how do you cool all these systems?
Right. It's like one of the laws of thermodynamics or something.
That's exactly
all right.
So I don't remember exactly which one, but yeah.
Yeah, me neither. It's been a while.
Yeah. So, but some creative ideas that people have been doing is, I believe Facebook, they took one of their data centers, I think it's the one in Oregon, and they put it up on a hill, and they, channeled the wind in such a way that it
cools.
Keeps
and I've heard of something that Google did is that they built an offshore server base and used the seawater. It's somewhere in the Pacific, and they use the seawater to actually cool their servers.
Yep.
Which is pretty innovative, but I don't think your mom and pop, cloud server shop can cool their servers using seawater.
Not seawater, but there are other ways of cooling systems, and this is kind of where a lot of the industry is going. Well, what do we do nowadays to keep the power down, to cool the systems, but keep them performing at that such high level? And it's a big challenge. From any small guy to the largest guy, they all deal with it. They have electricity bills.
No, certainly, and it's not just. I'm sure it has a lot to do with functionality. If your servers are overheating,
definitely.
So it's probably more than just your literal direct cost savings in electricity. There's probably other benefits. I mean, I've been to your server assembly line, and it's hot in there just because there's so many servers running at the same time. And all that heat is being transferred out.
But just to give you an idea, a traditional way is you have several fans, and they keep the system cool. They blow, they move the air, and they keep the system cool. And in typical data centers, you have hot aisles and cold aisles. And when you walk in there, the front is going to be really hot, the front is going to be really cold because that's where the air is getting pulled in.
Right, it's drawn from there.
Yep, and then the back is going to be really hot.
Okay.
And if you talk to data centers techs, they don't like that just because they get sick all the time. Because going back and forth. Yeah.
Really?
So it gets a little uncomfortable if you're moving back and forth. So, but there are new innovative ways of cooling systems and lowering power consumptions. We're seeing a lot of innovations in water cooling or unique positioning of data centers, as I mentioned, Facebook. So there's something called submerged cooling, where they completely sink a server in mineral water, and that mineral water removes the heat. So it's a lot more efficient. But then you have
now, does it matter what if it's Aquafina or Mountain Spring? Does that make a big difference? Or
I think it does, just because you don't want to fry your systems. So, but
okay. I hear Poland Spring is good for cleaning or for cooling.
Yeah.
All right, so we're going to talk about cooling and. It probably in a different podcast. Probably since it's such an important topic, maybe podcast 2, podcast 3.
Definitely, I would say it's probably one of the bigger issues.
Right, and I know that's where a lot of the advantages and the price wise. If you pay more, you'll have significantly less power consumption, and there's a lot of value to be created there, and a lot of money to be saved. All right, so let's talk about applications. Let's say I'm your typical server buyer. I'm one of your potential clients. What kind of company am I? What does my company do? Why do I need your servers?
Sure. Well, I'm going to ask you several questions if you were my customer, and I would be asking you, what are you doing? And I would try to dissect of what you're doing and to figure out what server meets your requirement. But I can give you a few examples of situations that I run into all the time. One example would be a database server. And what a database server is, well, where does a company store all its files, all those transactions, all those, or like a bank? Where does it store?
An Excel document?
Sure. Well, that's a small database. Imagine a huge Excel document, and then you have to organize it, and you have to search it somehow, and so on. And that's going to be your database. But you need power. You need a powerful server to search through all that, to organize it. And databases, they typically look for high CPU performance, and really fast access to your hard drives. So what we're seeing is the CPUs, you just get the higher end CPUs, but hard drives, solid state, because solid state is not a physically moving part, and it can access your files a lot quicker. So we're seeing these boosts in performance for databases just by going to solid state drives.
And you know what? I mean, just personally, I just got myself a new laptop. You're looking at it right now. And thanks to your recommendation, I actually went with a solid state laptop. And
I'm sure you like how it powers out.
Yeah, it's instant. Instant gratification. We live in a fast world. Bam, bam, bam. It's very quick access to all your files and stuff. I like the way everything opens up. So yeah, I could see that. So let's talk about number 3, which is
talk about number 6.
Let's talk about number 6. All right, so we'll pull the curtains. We actually made a list of a couple of these applications just because it's easier to organize. So what are we talking here? Research. All right, that's another good idea.
So we call this HPC, high performance computing, and what that means is, so you have a lot of these research firms, universities, all the medicine, oil, gas, all these companies are doing research, and when they're doing this research, they need powerful servers to analyze their data. I'll give you an example. I personally worked on a project where there's a telescope out in Argentina for NCSA, National Center for Supercomputing Applications, resides on U of I campus, and what they do is they study the dark energy. Fermilab built the telescope, and it checks the dark energy and they capture this picture, and then they analyze it. They analyze the change, they analyze what's happening, and so on. And they need a server to analyze all this data. Well, it might not be just one server. It might be a whole bunch of them, and they might,
Right. I remember a year or two ago you were telling me about some research lab, again, in the astronomy field, that ordered how many? It wasn't terabytes. It was like
petabytes. It's actually a project that they're working on. I don't remember the exact name, but it is the future projects of this dark energy. I think it's called Large Square Kilometer Telescope or something like that. And what it does, it takes a picture of a petabyte of data each day. And it takes a picture.
What is a petabyte? I mean, I don't even know that prefix.
Petabyte is 1,000 terabytes.
It's 1,000 terabytes. Okay.
Yeah.
So that's a lot of bytes.
Yeah, but keep this in mind. It's on a daily basis. So it's
right, and they need to store this information somewhere.
And I think they were storing this for 5 years.
Wow.
And they're storing this every single day.
Right.
So by the end of the year, you have 365 petabytes.
Wow.
And
okay.
It's just
that's more information than is necessary. Okay, but by my estimation, I mean, who could possibly do anything with that much info? But okay.
Well, I don't know. Maybe they'll find more black holes or something.
Yeah. All right.
Or another meteorite that's gonna.
Yeah. Definitely. All right. Never mind. Keep researching, guys.
Yeah.
So far we got what? What were the applications that we went over?
So we went over
databases,
hosting,
and research. All right. So what else? What would you say is the fourth most common, or just the fourth kind of category?
So one that we haven't really hit much is servers for smaller businesses or for just businesses overall. And these kind of servers would reside usually on site of a business, and they can do multiple things. Again, they can run the email application, they can run the database that the company has, like an ERP system maybe.
Oh, okay, right. A lot of these high-end systems require just tons of processing power and data storage space.
Yeah.
Okay.
Communication. How do you communicate? Or share files. So content management systems such as SharePoint or Google Doc is out in the cloud, and again, that's a server. But a lot of companies or corporations, they might not trust their files out
to a third party.
Yeah. So they're going to have internal servers that are going to do that as well. So content management could be another one. So.
Okay. Cool.
I think that concludes my list.
No, really. All right. So that just about covers the applications, right?
Yeah.
All right. So now let's talk about the components of a server. What's actually, inside this metal box that I get?
Sure. It's going to be very similar to your desktop computer, maybe a few more, but these components are going to be designed to specifically work in that environment that we talked about in that 1U or multiple U system and that high heat environment and so on. So just to give you a list of a few components is you have your motherboard, or well, you have your chassis, which is the physical box, right? You have the physical box called the chassis. You have your motherboard, which connects all the components together. You have your processor, which is your CPU and does all the processing power, and that's your horsepower. You have your memory or RAM, which does all the short-term operations, quick access to RAM. You have a power supply, a lot of times redundant power supply, to provide power to your system. You have your hard drive, which is your storage, and there could be different types of hard drives, such as SSD drives, spindle drives, and so on. And then you also have a lot of times things called like a RAID controller. What a RAID controller does, it provides redundancy and performance for your hard drives. So you want to make sure your data is safe. You want to make sure you can access it quickly. A lot of that functionality comes from a RAID controller.
Okay. Yeah, and I've worked at ICC for a little bit before, and I remember seeing RAID 0, RAID 1, RAID 5. Yep.
So there's a few different RAID technologies out there. Most popular are usually RAID 1, 5, and 6. RAID 1 is a mirror, which is a copy of your drive. It's going to be an identical copy, but it's pretty slow and it's not really efficient just because you need to have an extra hard drive. And, if a hard drive costs several $100s, well, now you need two of them. I actually skipped over RAID 0, but RAID 0 it's not a very common RAID technology used out there just because it combines two drives into one. So if you lose one drive, you lose all your data. So that's why it's not really common or really popular, but it is the most it is the fastest, so it gives you the most performance. So it's going to perform a lot faster than a RAID 1, which is a mirror. Another really common one is a RAID 5, which is a single parity. And what that means, easiest way of explaining this is, imagine you're writing your information on your drives. You basically write a little bit of information on every drive, so if you lose one...
Only a piece of it is gone.
Yeah, but it can still recover just because it wrote before, it knows what came before, it knows what came after, it can still recover it. Now, that's a very, very, very basic explanation, just a very high level. RAID 6 is dual parity, meaning you can lose two drives, but it works exactly the same way as a RAID 5.
Yeah. We'll have to do a whole episode on RAID. I mean, it seems like such a broad topic, and it's actually pretty interesting to me. So we're definitely, podcast 4, 5, one of these. We'll certainly definitely cover RAIDs in greater detail.
What I would actually cover is storage. Storage in itself, of how do you store data, and RAID falls under there, is very interesting. It is something that's heavily developing today, just because you need that performance, you need that reliability, and as we talked about earlier, you're capturing so much data now. Because everyone has, pictures and music, and it's all out there, not on local.
Yeah, I remember when I was I must have been 10, 11, there was a computer game that I really wanted. And
Age of Empires?
No. It was a different computer game, actually. I remember I had such a hard time convincing my dad to delete programs and files off the family computer so I could fit this game on. And the game was, I remember it was 90 megabytes.
Yeah.
Can you imagine that? 90 megabytes. I remember the entire hard drive of this computer is 500 megabytes, half a gig.
Wow.
And I don't know, this must have been like 96, 97 maybe? 98? Yeah. Something like that.
I still have some of those. We have a collection of drives, and I think I have like an old Western Digital 2 megabyte drive.
A 2 megabyte drive. Dude, that's technology. I remember the floppy disk, man. That was heavy duty, 1.5 megabytes, yeah. On a floppy disk, but they had entire drives that were just 2 megabytes.
Yeah, and it's huge too. It's like a brick,
wow. All right. Yeah. So yeah. What's that law that everything Moore's law is it?
Moore's law. Yep.
Moore's law that everything gets twice as fast and half the size.
Yep. Every 2 years every year it's twice as fast. So
twice as fast. Does that hold true? I mean, that seems like I know computer technology, grows by leaps and bounds in progress, but that's got to be an exaggeration. Twice the speed every year.
So it's typically related specifically to the processor. which is the compute, the horsepower, and it has been. And
Wow.
it has been true, and that is the driving factor.
Right.
Yeah. So what we're actually seeing is nanometer technology just shrinking, and you're getting a lot more powerful.
Nanotechnology.
Yeah. So you're getting a lot more. I think the processors right now are at 22 nanometers. So they're putting
Wow.
a lot of transistors on that one little processor.
Wow. All right.
We covered a little bit of what all these components do. So, and then they all just come together. Oh, networking is another big one, and we can actually cover a whole section just on networking. And we can
All right. So, well, I mean, for the limitations of this particular episode, let's do like a brief overview. So, I have a server. Let's say I imagine that a network requires more than one server. Am I correct?
That's correct.
All right. So let's say I've got two. Right. Why? I mean, first of all, what is a network, and why would I be interested in networking them together?
So networking actually is just how your servers or computers and how everything communicates with each other. Now, it gets very interesting just because of the speeds, of how fast you can transfer data, of the latency of, well, I transferred the data, but how, that you responded, and that's a little bit off, but okay. So, how fast we transfer data. Networking also is what kind of protection do we have? So we have like firewalls, and how do we balance the information between multiple servers? How do we? Well, there's a lot of different areas.
Andrew will be the networking.
Yeah.
All right.
And
so
storage.
Storage and networking we're going to leave to Andrew. And you think Andrew will want to participate in this podcast?
Definitely.
Yeah, and he can. I'm sure he can. He walks the walk. I'm sure he could talk the talk.
Yeah, definitely.
All right.
More than just talk the talk.
More than talk the talk.
Yeah,
all right.
He can do this for hours.
All right. So we're right around 25 minutes. Is there anything else you want to discuss? Any other kind of high level overview stuff?
Not that I can think of. I think for first, this is pretty good.
All right, Alexey. So this is actually the first podcast you've been on. I mean, technically the first podcast that I've been on as well. But I listen to so many every day that I feel like a podcasting veteran already. But what did you think?
I thought it was pretty good.
You thought it was fun?
Yeah, a little bit rough to start off.
Yeah, I was a little. I saw you were a little nervous at first, but you seem to really loosen up and catch your stride. And that's really good.
Yeah, just like the Bulls.
Yeah. Sure. All right. So we're located in Chicago. We're big Chicago sports fans here. So this has been Server Talk. I'm your host Mike. I've been interviewing Alexey of ICC. The website is www.icc-usa.com. Go check it out.
This has been Server Talk with Alexey and Mike. For more information on anything related to servers, please visit www.icc-usa.com.